Alright guys, the next transformation we are going to talk about are going to be reflections, So the first transformation we talked about were dilations, and just to review what a dilation was, that's when your image, your pre-image, got either smaller by a reduction or it got bigger by an enlargement. So remember, with dilations, that's when we're using a scale factor, so we're multiplying. Then the second transformation we talked about was a translation. And a translation just means you're sliding your picture from your original image or your pre-image to your new image or image, just depending on the way they word that. So with a translation, if I were to take this trapezoid, I'm just either sliding to the right or sliding to the left or sliding up or sliding down. So we could have a horizontal change left to right, or we could have a vertical change up or down, or you could actually translate it both the X and the Y. So now we're going to talk about reflection. So just kind of reviewing that vocabulary. If you stop and think about what a reflection is, when you look in the mirror, you have your reflection, okay? So you're the same person in the mirror, it just kind of looks backwards. So for example, if you have a freckle on your right side when you're looking in the mirror, it looks like it's on the other side, so it's kind of different. If you've ever seen like where you have a picture, where you're looking in the mirror and you have words on a shirt, they look backwards of how it's reflected. So we're kind of use that to help us to understand what this is. So a reflection in geometry is simply going to be a flip over a line. And that line can either be the x-axis or the y-axis. Okay? Now, important to note, a reflection preserves congruence. And what that means is that the shape is the same. And the same size. Okay, just like a translation preserves congruence, because you're just sliding that picture one way or the other. So we are preserving congruence with the reflection. Okay, so let's go ahead and look at this, and it makes a little bit more sense once we see the examples. And just like what we did with dilations and translations, we're going to figure out how to write the rule for this. So it says reflect the trapezoid ABCD across the y-axis. Then draw the translated image on the grid and label the vertices A prime, B prime, C prime, or D prime, and complete the table. So remember, with original image, we can also call this pre-image. Sometimes they call it that. And with new image, sometimes they call that just the image. So if you ever see pre-image, that means the original, because what you started with pre means before. And if you just see the word image, that means your new image where you got to. So just something to think about. Okay, so we're going to reflect it across the y-axis. And y, remember, is vertical. It's up and down. Okay, so if this was a mirror image, we're going to reflect this over. So again, think about that like if you were looking at a mirror and you had a t-shirt with words on it, the letters are going to look a little backwards. So let's kind of think about that. Another way you can think about reflection is if you fold this over. If I were to fold this trapezoid over like that, I'm going to make it a little bit darker so we can see it and kind of see what happens when we reflect it over that y-axis. So made it a little bit darker. So let's see. If I draw it like that, you guys can see right now, if I zoom in a little bit, see if you can see that. See that little marking? It actually looks like this now. So it's still at the same height. See if we fold it over like that? It's still at the same height, but this slant's not on the right anymore. It's actually on the left. Okay? So if these are reflecting over, let's kind of think about that. Okay? So let's, first of all, we know it's going to be reflected over. They're going to be the same height, but this is A and this is B. And now that means A is over here and B is over there. So that's kind of something to think about too. So if you actually count for, let's look and see our original ordered pairs, and I'll tell you what you're going to do. The original ordered pairs for A, you start at the origin, and go to the left, you're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 up. So 9 to the left is negative 9, and 9 up is positive 9. Okay? So if we think about it, if I reflect over the y-axis, I'm still at the same height, so my y is still 9. But over here is quadrant 1, and if this is 9 units to the left, then that means the opposite of it, flip over, is going to be 9 units to the right. So that means I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And watch this. That's going to overlap just like that. So this is A prime. Okay, something to think about. So A prime, I'm still the same height because I'm just reflecting over the y-axis, but my x is now positive 9. Okay? And again, this will kind of make more sense once we see a little bit more examples. Well, now B, let's see what the original order pair for B was. 1, 2, 3, 4 to the left. It's the same height as that A, so it's going to be negative 4, positive 9. So B prime, if I were to fold that over, okay, so kind of think about here, and you're going back to the y-axis. Well, from B to the y-axis, it's 1, 2, 3, 4 steps. So if I go back, 1, 2, 3, 4 steps. So you can kind of think about it that way. Okay, it's just a mirror image, so it's flipping over that. So that means that B is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, just like that. Okay, so if you're reflecting across the y-axis, we can see this is quadrant 1, this is quadrant 2, and in quadrant 1, all of our x's are positive, and all of our y's are positive. Just like that, how we're seeing where they're reflecting over. And in quadrant 2, all of our x's are negative, and all of our y's are positive. So that kind of helps you to see, to make sure you're not forgetting those negative signs when you need them. All right, so let's look at C. That's negative 2, and y is 3. So if I were to reflect over, I'm still the same height, and this is 2 away, so if you count it, see how it's 1, 2 away from the y-axis, so we need 1, 2 away from the y-axis over here, and that's positive 2, positive 3. Hopefully you're seeing a pattern. All right, look at letter D. That's going to be negative 9 and up 3. Oops. Almost made my parentheses, so that's a kind of funky 3. It's negative 9, 3. So D prime, again, if we reflect over, see, here's A and here's D. So if this is A prime, then D prime needs to be right here. And then we can connect our quadrilateral, which is a trapezoid in this picture. So here again, if you draw it real dark and you see how it can fold over, that makes sense of how it works out. Okay, so C prime is right there. So D is the same height, so that means my y is going to be the same. But I'm 1, 2, 3, 4, 5, 6, 7, 8, 9 to the left. So if I reflect over, I'm going to change that and be 9 to the right. Okay? So let's think about what we're looking at. If we're in quadrant 2 and we reflect over the y-axis, we're going to be in quadrant 1. So both of them are the same height, so let's see what happened. How did your x coordinates change? Well, negative 9, 9. Negative 4, 4. Negative 2, 2. Negative 9, 9. So the x coordinates are the opposite. They're the opposite of what we originally started with, because the opposite of negative 9 is positive 9, the opposite of negative 4 is positive 4, and so on and so forth. Okay? How about the y coordinates? The y coordinates, let's look. 9, 9, 9, 9, 3, 3, 3, 3. So they stayed the exact same, and that makes sense because when we reflected over here, we are still at the same height. So the y coordinates stayed the same. You can prove that with the picture. Okay? So now we're going to use the answers from part A and write a generalization rule in XY form. So remember, whenever we're writing this rule, we always say XY is the original and then to the new. Well, here's what we can say. The y's we know stayed the same, but the x's, we have to think about how we can represent the opposite. So think about this. If negative 9 was my original x, I can multiply that by a negative 1, because a negative times a negative is a positive, and negative 9 times negative 1 is positive 9. Negative 4 times negative 1, positive 4. Negative 2 times negative 2 is positive 2. Negative 9 times negative 9, or excuse me, negative 9 times negative 1 is positive 9. So we're actually going to write a negative here, and this is something really important for us to know. The negative x is in the rule, in this rule, doesn't necessarily mean that they're always going to be negative. So what this negative x in the rule means is the opposite. And what the opposite of is of your original x values. And the reason why that is because you are multiplying by a negative 1. So very important for us to know that that doesn't necessarily mean the x's are always going to be the opposite, a negative. It means they're going to be the opposite of the original. Remember, in our new image, this x is like what was your original x. So we're doing a negative 1 times your original x, and our y is staying the same. So that's what happens when we have a reflection over the x. Okay? So it's like you're multiplying a negative 1 with your x's to your original ordered pairs, and your y's are staying the same to get your new image. Okay, let's look at the second part. We're going to use that same table here in a minute. So now it says reflect the trapezoid ABCD across the x-axis. So now I'm going on the x-axis. Remember, the x-axis is horizontal, so that's from right to left. What affected the reflection how on the x-coordinates and then the y-coordinates, and then we're going to write a rule. Okay, so the original image, or the pre-image, is what we started with. And the new image is, we can also say just image. So again, we need to know that vocabulary. So the original image, this was not my original image. That was my new image when I reflected across the y. So this is still my original image. So I'm going to use all of these ordered pairs as my points. Okay, so my original image was A, B, C, and D, and negative 9, positive 9, negative 4, positive 9, negative 2, positive 3, and negative 9, positive 3. So now we're going to see what happens when we reflect across the horizontal or the x-axis. So we're going to still use this picture. Okay, so if I have this trapezoid, because this is my pre-image, and I were to fold it across the x-axis, that's horizontal. Well, this is quadrant 2, so remember in a coordinate plane, it goes 1, 2, quadrant 3, and then quadrant 4. Just to kind of make some estimate or some helping out, my x's are negative and my y's are negative over here. So all your ordered pairs in quadrant 3 are negative and then negative. Negative x, negative y. Then quadrant 4, all your x's are positive because we're going to the right, and then we're going down, so positive, negative. So that just kind of helps us out when we're going to do this. So before I even translate this, or not, translate it, when I reflect it, because translating, remember, means I slide. If I were to fold this over, this line right here, like that, Well, now A is here, this was B, and then this was D, and this was C. So that purple is when we did the X. So we can see that from left to right, they're staying over here, and then it's just going down like that, okay? So if we were to draw that, well, it's the same distance from the left of the origin. See how A and D are over here? Still the same distance, but now it's in the other quadrant, so now the actual height has changed. Okay, over here the height stayed the same. Over here, from left to right, they're staying the same, but up and down they're going different. Okay, something to think about. So what that means is if we reflected across the X, then they're the same distance from left to right, so that's -9. But now instead of being up in quadrant 1, like it was in the reflecting across the Y, we're going to be down here in quadrant 3. So if I were to be the same distance from the right, from the left, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's what we're going to do. We're going to go from here to here is 9 steps. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's A prime. And then D, we're reflecting across the X. We'll count to the X-axis. 1, 2, 3. So we're going to go 1, 2, 3. So just the opposite direction because this is your mirror. Think about your mirror image. Then C was 1, 2, 3. So 1, 2, 3 right here. That's C prime. This C just stands for coordinate plane. And then this one, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to do the opposite direction. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, that's what we predicted when we folded it. So when you see the picture, it really helps you out. So we can see now that my trapezoid, when it's reflected across the X, if the X-axis was my mirror, I'm the same distance from the left, so that means my X-coordinates are going to be the same, but what changed are my Y's. See, here's negative, X negative, so my X's are still the same distance to the left of the Y-axis in the ordered pair, but their height has changed. So that's what we're going to look at. So if you actually pause the video and take these ordered pairs, you can see that this is going to be -9, -9. This is going to be -4, -9. C prime is going to be -2, -3. And D prime is going to be -9, -3. Okay, again, that makes sense because if we were in quadrant 2 and we reflect across the X-axis, we're going to be down here in quadrant 3 where all your X's are negative and all your Y's are negative. Okay, so let's think about it. Which ones changed? Did your X coordinates change? Let's see. The X coordinates right here are the same. So we have -9 and -9 are the same. -4 and -4, -2, -2, -9 and -9. So again, that makes sense because we were the same distance. When you look at that right there, we're the same distance from the left of the origin. So we're going to say the X coordinates stayed the same. But 9, -9, 9, -9, 3, -3, 3, -3. So the Y coordinates are the opposite. The opposite of what we started with. Okay? So XY was my original. And just like we said earlier, the opposite, we're going to use a negative sign in front. So what stayed the same was the X, so we're just going to put X. And what is now the opposite is Y. Again, this negative just means it's the opposite. So if we were in quadrant 2 and we folded over across the x, reflected over, we're now in quadrant 3. And that we can see our y values are physically changing. So that's why we put a negative sign there. And it ended up that these were negative, but that's not always the case. So remember, this just means the opposite. That's where a lot of students get confused. Okay, again, you can think about this as a -1 times your original y. So 9 times -1 is -9. 9 times -1 is -9. 3 times -1 is -3, and so on and so forth. Okay? So here's the thing. I want you to try these on your own, but here's kind of the trick, if you haven't noticed it. If we reflected across the x coordinates stay the same. So what's changing are just your y. When we reflected across the y-axis, so you can see this, when we reflected across the y-axis, we saw that the y coordinates stayed the same. So that's kind of the trick. If you reflect across the y stay the same, the x's are the opposite. If you reflect across the x's stay the same, the y's become the opposite. So that's something for you to think about. Okay? So what you're going to do on these two, and then you can check in with your teacher, make sure you get them right. It says perform the given transformation, record ordered pairs of corresponding points in the table, and then write the generalization and the rule for the points on the new image and compare to the original. So I'm actually going to help you with the rule, and then I want you guys to fill these tables out and see what you can get, okay? So here's the thing again. If you reflect across the y, right here, then the y's stay the same. If you're reflecting across the y, you're staying at the same height. So that means that my rule, my y's stay the same, then the x's change. Okay? If you're reflecting across the y's stay the same. If you're reflecting across the x, then that means, sorry, that arrow got messed up. That means your x stays the same and your y's are the opposite. Okay? That's the easiest way to remember it, but you can actually see with the picture. If this was my original image and I reflect across the x, then I'm still the same distance to the right, but my height changed. That's why I have a negative y. It means the opposite. So knowing that rule, let's see if you can fill in these tables and go from there. Okay? So after you fill in those tables, check in with your teacher and see how you do. And then, of course, let us know if you need help during the assignment.